So how do we set upper limits and lower limits? So in Java's generics perspective, upper limits or setting upper limits and lower limits is known as the bounded type. I've already talked about bounded types or setting upper limits and restricting your users or people who are going to use your code into a certain type of or certain data types that you will only allow inside your class to be used. So how do we do that? It's very simple. What we have to do when it comes to setting upper limit is that we have to extend the parameterized type inside those angle brackets. So let's have a look. So first I'm going to create a new class, and this class is going to be named as bounded types. So let us actually imagine a scenario where we want to find an average. We have two options in here. First, we can actually look for the average from a collection or a list of integer numbers, and we can also look into an average answer that can be gained from a list of decimal numbers, and decimal numbers are more precisely represented with the data type of double inside in Java programming language. I hope that you're quite familiar with that. So when it comes to understanding how average works and how to calculate average using generics, it's quite essential to understand these bounded types. Let me demonstrate how to actually use generics to find average without the use of bounded types. So let's just do that. So here we have a class called bounded types, and then as usual we're going to set the parameterized type. We're going to take only one single parameterized type in here, and then we're going to, because we need a collection or a set of numbers, that's why we're going to declare a class an array instance inside our class. So let's do that, num array, and then obviously we're going to create the constructor. In this case the name will be the similar thing with the class name. So inside the constructor we're also going to use the array data type, and then we're going to call it a. We're going to assign a to our class's instance variable or the instance array called num array. And then simply calculating average is quite simple. It's actually not quite, but very simple. So let's have a look. So in here we're going to look into a new method that we're going to call from our wrapper class called number. The problem in here is that the compiler wouldn't actually understand what we are trying to do inside our code. So let's have a look. So we are going to call it average, and then we need a double sum variable where we're going to store the results that we have obtained from averaging all the values. So once we obtain the result, we are going to return that result to our compiler or to our caller. So let's do that. It will be 0.0. The reason why I have used 0.0 is it's actually very simple, because in here I'm declaring a variable called double. I'm declaring a variable called sum, which has a data type of double. So because decimal numbers in real life are actually used to store stored inside variables with the double data type, that's why we're going to tell the compiler that we're going to store a value that's going to be a decimal inside our sum variable. So we need a correct data type for that, and in here the double data type will actually meet the requirements in this case. Now, in order to go through all the average, in order to get the average of all the numbers, we're going to need a loop in here. So let's write that loop, int I 0, and int should be less than this num array length and I plus plus. Then what we're going to do is that we're going to add each of those numbers to the sum variable, and we're going to do that by num array, and similarly we're going to return by dividing this sum by the entire length of the array. So let's do that, and this is going to be num, oh sorry, I missed one of the most important method in here, and this should be double value. So I will actually discuss after I finish writing this entire piece of code. This num array length. So the entire code doesn't actually contain any sort of bug in here. This one, which is underlined as red by my editor, there is a reason for that. The reason is that although I'm creating a generic class in here, the compiler wouldn't actually understand what I'm trying to say in here, which means I'm passing a parameterized type and I'm saying that I need a collection of numbers, and the compiler is quite okay with what I say up until this moment where I have declared a variable called sum. Then when it enters the for loop and then it sees that I'm calling each of the number inside this array or inside this collection, and I'm also going to take in the double value from that array from each of those numbers, then it gets quite confused. The reason is that in my mind as a programmer, I know that I'm going to use the methods from a class called number. So this double value is actually a method that's coming from a class called number, which is the superclass of the integer wrapper type and the double wrapper type. So we have looked into the integer wrapper type class. If you could remember, I may go there and I can show you that I've already worked with. Sorry, it's not here. So, okay, it's here. So we have looked into how to work with integer wrapper class. We have also looked into how to work with string wrapper class. So rather than passing in an integer wrapper class, you can also replace this integer with a double wrapper class. There's also a double wrapper class we can use. So if you want to use a double wrapper class, you just need to replace that integer with double. So I'm not going to do that right now in here. I'm going to rather do that later on when we finish our discussion in or when we fix the bug that is contained inside this class. So the double value method is coming from the class called number, which is which is the superclass for the wrapper class called integer and double. As a programmer, I know that, but I need to tell the compiler so that the compiler can also understand what I'm saying. In order to do that, we need to implement what is known as the bounded type, or more specifically, we're going to implement the upper limit in here, and the upper limit is going to be the inclusive one. When we look at the lower limit, it's going to be the exclusive one. So let's have a look. So what we're going to do is that we're going to extend, or we're going to say that the parameters type t extends from the class called number. You don't have to import this class. Your JDK will automatically do that for you. So what we're doing in here, and if you could actually go down and you'll see that the compiler on my editor has removed the red underline. So what is happening inside here is that I'm telling the compiler that the t, or the parameters type, is actually a subclass of the number superclass. So it means that I can use the number superclass when I'm calling this bounded types object inside this main method. I can also use an integer type instead of t. I can use a double wrapper class instead of t. All three possibilities are acceptable in this case, which means I can use number, double, and integer classes instead of this t. So as I've already mentioned that this upper limit will be an inclusive upper limit. It means, as I've mentioned earlier, we can use the three types: number, integer, and the double classes. So as I've already told you, that the number can be used, which means it's an inclusive one. On the other hand, if we're going to use the lower limit, we can't use number. We're going to go there after we have done with the upper limit part. So now the bug has been fixed. We can call this class inside our generics class. Let's save this. Let's go back to our generics main class. And then what we're going to do is we're going to import the class, import generics tutorial dot, I didn't miss an I, and then I'm going to call the bounded types class. So now what we're going to do is bounded types, then I can pass integer and I'm going to call this average, or maybe we can call this average object, and then we're going to assign an instance to it, and the instance will be bounded types integer, and then this will have a constructor, and we're going to pass an array or a collection of values inside this constructor. But before we can pass that, we need to create an array ourselves. So let's call this int nums, not int nums, sorry. We're going to call this integer num. So it's very important. I'll show you why it's very important. Let's create the collection first. 1, 2, 3, 4, 5. I guess 5 will be alright. And there we go. And we're going to pass this nums in here. So let's see where is the problem. This is actually a collection, so it will be an array. And I have fixed the problem. Then I'm going to print out the result on my console. So I'll call in the system out println method, and I'm going to pass in the average obj, and I'm going to call the average method from the object called avg object. I guess I missed a parenthesis somewhere. Okay, now I'm good to go. So what I've done in here is that rather than creating a primitive type, it will actually, when you create a primitive type, it will actually cause a problem. If we try to change this, you'll certainly see that this instance is not acceptable. It's telling me the constructor bounded types integer int is undefined, which means it actually expects me to change this t into int, and that's not what I want to do, because I want to make it generalized so that I can use integer, number, or double wrapper classes in different instances. I don't want it to be hard-coded to only integer, or I don't want the constructor to only accept integer arrays, or more specifically primitive integer arrays. So I want to use a wrapper class, or perhaps a wrapper class that's going to act as my data type for this variable called nums, which happens to be a collection of numbers. So let's have a look after we run this code. So let's run this, and there we go. We have got an average of 3.0. So now let's do something different. We're going to call in the double wrapper class, and we're going to see what sort of answer do we get, and what are the changes that we need to make. So let's change this double. We also need to change it in here. Double, we're going to pass in the parameter as type double, and the problem in here is that when the compiler actually looks at the code, I'm passing in all the integer values, whereas I'm telling the compiler that my variable will contain all values that are decimal numbers. Are they decimal numbers? No, they're not decimal numbers, they're integer numbers. In terms of human language, we can make them decimal numbers. So how do we do that? We only need to add a 0.0, and there you go. The first underline is removed. So let's change the numbers actually. So this is going to be a random 21.212 and 3.33. Then we're going to say 4.5 and maybe 45.5, and that will do the trick. So let's run the code again and see what we get. So there you go. The average is 16.89, and that's all. And that's the actual correct answer, and it is in between the lowest and the highest number, so it's actually quite correct. It's actually correct nonetheless. So there we go. We have looked into the bounded type, and we have specifically looked into the upper limit. In the next segment, we're going to look into wildcard and how we can extend, or how we can actually include an interface type inside our parameterized type.